Hey, industrial professionals, before we get into the show, I want you to be aware of a free ebook that we have out on Industrial Talk. It takes and expands upon the these are common, 5 elements that make companies successful. This is it. 1, they educate. 2, they collaborate. 3, they innovate. 4, they invest in the culture of the organization. And then 5, are able to, in an effective way, communicate to the masses of what they do in an effective way. Those are the 5 elements. That's what the book expands upon. Go out to Industrial Talk, download it, and while you're at it, get the free workbook too as well. Now on to the show.
Welcome to the Industrial Talk Podcast with Scott MacKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, once again, welcome to Industrial Talk. Thank you very much for joining this platform and your continued support of the #1 industrial-related podcast in the universe that celebrates industry professionals all around the world. You're bold, brave, you dare greatly, you innovate, you collaborate, you solve problems each and every day. That's why you're making the world a better place. That's why we support you on Industrial Talk. If you can tell by the buzz in the background, if you're looking at the video, you can tell people are milling about the place. We are just right on site, Reliability Lab. This is on the floor. This is called Xcelerate 2025, brought to you by those wonderful people from Fluke Reliability. Go out to Fluke Reliability, put it in your URL, and you'll find them, and you need to connect with them because you want to be better in reliability. You want to be better in maintenance. You want to be better in your asset management. Fluke Reliability, make it happen, Captain. All right, in the hot seat, he was up on stage. He's a celebrity. Jeremiah Woodford is the gent. What's the company's name?
Verisen.
Verisen.
It's Latin for truth.
Whatever it takes. This is true. It's over my shoulder. They're in the same neighborhood on this floor. Yeah, your people are very nice. Just nice folks. I went over there and
a great team. We have a great team.
Yeah. No complaints. I wouldn't complain. I wouldn't sell them out. Why would I do that? Absolutely. All right, for the listeners out there, Jeremiah, give us a little background on who you are.
Yeah, been in heavy industrial maintenance and been in and around it for 20 plus years. Born and raised in Southeast Texas, still reside in Texas. We worked in the oil field, I was a roughneck for a number of years, and then as an outdoor machinist in refineries and chemical plants, and finally went and got my computer science degree and got into software, and I tried to run away from the plants as soon as possible, but ended up getting into maintenance software. And got back into the plants. Been in and around it for 20 plus years, traveled the world, worked with some of the biggest industrial companies in the world, and I don't know, I'd like to say best practices in some of these things, but I've seen good and bad.
Yeah, we've been having this conversation forever, it just seems like,
Absolutely.
But I think the technology as a whole is able to keep up, and now we're at a point where we can truly leverage these solutions in a way that makes sense. I mean, beforehand it's like, I don't know.
Yeah, coming in and around, I've been mainly around EAM software for 20 plus years, and helping people buy and implement those software systems, and listen to maintenance people complain about how bad they are. And
yes,
and you're just seeing workarounds and trying to figure out how to make the thing work, and ultimately creating a ton of data. And I think what the perception has been is bad data, ultimately. Yep. So now I'm at an actual AI company, and I say actual is because it's such a buzzword that everybody uses today.
It is,
and and I think it's overused, but what we do is it's a large language model.
Is it? Okay.
So it was a joint venture with Georgia Tech Institute of Technology, and they took Stanford's open source large language model and started training it on MRO data. And what's really cool, I found these guys a couple years ago when I was at an unnamed 3-letter EAM provider, and
I gotcha.
And really wanted them to acquire this company for their technology. And then the more I learned about it, the more excited I got about it, and I said, I got to come work for you guys. And,
very cool.
So that's how I got started with them, and it's some really cool tech.
For that listener, just from a level set perspective, give us a little, what does MRO stand for?
Maintenance repair. Some companies, depending on what industry you're in, operations or overhaul.
Okay, good deal. Want to make sure that everybody's on the same boat. All right, take us through the company. What from a basic perspective, what are you trying to accomplish?
Yeah, so it's really straightforward. We're trying to help you determine if you're a big industrial company that's buying and stocking maintenance spare parts. We're plugging into your ERP and your EAM and helping you determine the stocking level of those parts. There's a lot more to it, but at the base, that's what we're doing. So we're leveraging all that data that's been created for years and years and years, and most people think a lot of it's bad. And the reality is we can make sense of it, and that's where this AI, large language model, is really powerful. And just give you an example. So we're pulling your master data catalog. So the master data catalog is your internal parts list that your maintenance teams need to keep, the boiler, the chiller, or whatever, whatever industry you're in. We operate a lot in industrial manufacturing, but we have oil and gas and mining and so forth. They all have same problems. And a lot of the crux of those problems is the poor naming conventions in those catalogs. So I'm a maintenance guy, and you rely on me to tell you what I need to keep this machine up and running. And I'll do my best to describe that bearing and the size of that bearing or that pneumatic cylinder and the stroke and bore of that pneumatic cylinder, but everyone's going to describe it slightly different. They're going to abbreviate it slightly different. So everyone views this as like an insolvable problem, and this is where this large language model is really cool in the sense that it knows that air and pneumatic is the same thing. It knows that the bore stroke on a pneumatic cylinder, 0.25 or 1-4 is a quarter. It knows that's the same measurement. It's been trained on it, and it's constantly learning. So every time we put more data into the system and users are interacting with it, it's learning. And to be clear, though, this is not some nefarious AI that's going to break loose one day. It's still it's still a dumb model in the sense it's very pointed, purpose built to solve a very unique problem.
Yeah, every time when I was deploying systems, it was always how do you scrub the data? How do you normalize that data? How do you make it relevant? Because there's a lot of bad data in there, shall we say. Are you indicating that the solution can do that and scrub it and go back and do the heavy nobody wants to clean data. Nobody. You don't. Nobody.
Time and time again, being in the EAM software world, you're ripping and replacing some other older legacy system, and you got to go down this data cleansing process, and then you talk about we've got how many years of history are we going to migrate over if we migrate over. We're not a data cleansing house. We normalize that data on an effort to help you determine that this bearing at this plant hasn't moved in 5 years, but you've got the same bearing at this other plant that's moving fairly being used on work orders, and you should transfer it to that other plant or optimize at a network level. So our goal is, we will identify duplicates and merge those duplicates in our system, all in an effort just from, so you've got 8 plants in our system, you're buying the same parts, but they're all named 8 different name numbers, different part numbers, but we can, our large language model identifies these are the same parts, and if you agree they are the same parts, then we can help you start looking at your suppliers. Is the supplier, who's the best supplier for this part out of those 8 plants? This supplier is giving you the best price. They're delivering consistently on their lead times, and this part is the most reliable from a usage perspective.
That doesn't happen overnight. I mean, if I came to you and I said, "Yes, I am a manufacturer. I'm Acme, a manufacturer, and I hear what you're doing, and I think I'm excited, and I want to get a better handle on that, or whatever it might be." I have problems. And I mean, where do you even begin?
Just give us your data. So this is
I even have problems with that.
So we hear it time and time again. Every time I'm training a new team right now, and it's what's really unique about this is I don't really have I compete. My biggest competition is do nothing. Most people look at this problem as unsolvable, or
look, I'm there. That's a tough one.
So what our 90% of our customers are in the same boat. We demo the software, they go, "This is fantastic. I don't think our data is going to work in this software."
Yeah.
And we got acquired this company. We moved from this system to this system. I don't see how it's going to work. So give us your data. We'll put the data into the software. We'll show you what we can do, and then we'll show you the business case. And one of the really cool things, what I like about what we're doing is this market that we operate in is these legacy software systems, these EAMs. It's all user-based. It's all, they approach this market still from a very legacy lens. And what I mean by that is that, I'm in maintenance, I'm in operations, or in a heavy industrial manufacturing. I need to digitize a process. So this is, kind of 20, 30-year-old mindset of, all right, let's capture it into a form that goes into a relationship database, and then we report on it. And maybe it falls into some type of workflow. But what we're trying to do with our system is, how do we automate this? So if you look at a lot of the companies today, these big industrial companies, a lot of the employees are data entry people, just trying to keep these systems up and running.
Yeah.
And what gets me excited about what we're doing is my goal and what we're trying to build here is a system that takes away those menial tasks. I don't want maintenance people behind a screen going, yes, this is the right part, or no, this is not the right part. We want them out in the field doing their job. Maintenance guys don't like using maintenance software, being asked to fill out a bunch of forms on a computer. So that our goal is to try, from the space that we occupy, is to try to automate this as much as possible. And a key metrics that we're tracking in our software is, the longer you're a customer in our software, the less time they're actually in the software. They're letting the AI do its job.
How do you interact with eMate? What does that relationship look like?
Yeah, so we're a strategic partner of eMate. We have an integration, standard integration for X4 and X5, and essentially what we're doing is we pull all your master data catalog, your work order history, your procurement history, any of the purchase data, and to be clear too, if you have, most of your eMate customers are going to have an ERP that you may have some loose integration with. Mm-hmm. In certain cases, depending on how that integration is structured, we'll pull from the ERP as well. So we have customers that are in SAP and Maximo, and we're agnostic in that sense, but the Fluke partnership is strategic in that sense that we have a tighter integration. And so ultimately the goal there is that as we pull all that data, and then we start making stocking recommendations. So if you log into our software, the AI is going to say, here's a bearing, you've got 10 on the shelf, your min-max is 10 and 11, but you only use it once a year, and your lead time is 2 days. So it may say the new recommendation is 3 and 4. And if you agree, then it's going to go back into eMate and change the min-max. But it's always on listening. So in that example, we're also tying that bearing to the asset. So if that bearing's used on a really critical pump, most critical pump in operations today, and if that, so that is maybe, if you're, depending on what your criticality metrics for your asset is, maybe it's ABC, the bearing's going to adopt the asset criticality. So it's really important for us to know how critical that spare part is. So that's where we're bridging the gap between procurement, supply chain, and maintenance. And from there, what we're going to do is, procurement knows that they don't know how important that bearing is. Maintenance knows that, but procurement knows I can get this bearing from Grainger, McMasterson. Right. Lead time's super short, so it's not critical to source it. So from that perspective, what we can flush out is, okay, this is really critical to operations and maintenance, but it's not hard to source it. In that example, we're going to downgrade the criticality, but we're constantly monitoring it. So if something changes, like now, making this up, now you got to go to Germany to get this bearing from the OEM, and your lead time jumps to 6 months. then it's going to pick it up immediately and change the stocking strategy and the criticality.
Are you asking me to be in another system, or can I use eMate, or how do I do from a user perspective?
Yeah, it is another user interface to the system. And typically the users of this system are going to be your material managers or your sourcing procurement people. And it's usually in the beginning, in the first 6 months of our software going live, they're in the system about 20 minutes a day. And maintenance people will get notifications because typically like critical spare parts, you don't want your sourcing procurement people to be able to prove they're going to immediately accept all decreases in recommendations. So we have workflow in the system that will anything that's a critical A or B in the system have to go to these maintenance people for approval. But what's really cool about our system and the AI, we're using explainability, and it's using natural language processing to explain why it's making this recommendation. Meaning so the maintenance guy would get a notification that, hey, they want to decrease this critical A part. The immediate reaction is like, no, I need this part. But if you read the explanation and you see this thing, you've got 10 on the shelf, you haven't used one in 2 years, and even if you use one, you've got 9 more. So, and the recommendation is maybe 5 and 6. I mean, making this up.
Right.
And so you're not really putting anything at risk. So it's really, from when you see it in that perspective, it's pretty basic understanding. And then so if they agree to it, then immediately that goes through a workflow approval process and pushes back.
Do I have a dashboard? I hate to say it, but do I have a dashboard with these recommendations? And if I log in and it's like, hey, we realize that we need to increase this inventory, decrease this inventory, we've got a part over here. You're trying to just optimize that whole supply chain.
That's right.
In such a way that I'm getting real accurate bottom line value and not incurring costs where I have to incur costs and incur costs where I have to, and so on and so forth. You're optimizing that.
That's right, absolutely. So we, from my perspective, we talk a lot about decreases, but just as important, we identify the increases that are needed as well.
And let's say your system identifies an increase and saying, for whatever reason, these bearings, you're going through these bearings a little bit faster than you should. Is there some logic or analytics that say, well, why in the heck are we doing that now? Why are we going through more bearings? Why, what is that? Why?
Yeah, so we have key data points that we're fleshing out, and we're constantly improving this. Our data scientists team, we're 75 people globally, and half that team are data scientists, engineers that come from like Georgia Tech and others that are mechanical engineers that are looking at how do we improve these data models to really help tie to reliability and uptime. To give you an example, I did a project with a super major in the North Sea, and one of their big initiatives were, like, we want to optimize inventory, but we don't really care about reducing inventory. It's a production platform, I think it's $700,000 an hour if it goes down. And you're out in the middle of the North Sea, and if you don't have the right part when you need it, they have to helicopter or fast boat it out to the platform.
Yeah, it's a no-brainer. You have their part.
Right.
Yeah.
And so through this process of helping identify these are your critical spares, and on those platforms you have very limited space. So in this process, we helped them clean up so they get a bunch of stuff that was on the platform that shouldn't be on the platform, that doesn't move, and get it back to the shore-based warehouse and get the really critical spares on the platform. And then help, and so in correlation, so they were actually able to improve the reliability and uptime from a number of measures. I'm not going to claim that we were direct, but we correlated that. Now we reduced their helicoptering and fast boating parts out. For the 2-year period that we were tracking it, there were none that were fast boated out or helicoptered out, and the splatter chart actually correlated directly with their reliability and uptime improvements that they had.
We talk about criticality, of course, of the asset and ABC or 1, 2, 3 or whatever the approach is. Is that also fed to your system? Because if I have the CMMS or asset management software, whatever it might be, That's the system of record.
Yeah, absolutely. But we want that data, absolutely. So we absolutely want to see the asset criticality is vital. So the way we've built our system and the way the AI models are working is we're going to ingest the asset, the equipment name, the criticality of that asset, and then we're constantly monitoring if anything changes. Typically equipment criticality doesn't change, but you do obsolete pieces of equipment, right?
Oh yeah, you do.
You work it out. You get the newest, latest, greatest compressor from Siemens, and that replaces it. So any of those parts associated with that asset, it's really important for us to have that purview. So we have customers today that are tracking as they obsolete older equipment. They want to make sure those parts that were just used for that. They want to identify the parts that were just used for that equipment, and do they need to transfer it to another plant that does still use it. And so that's part of our system is we have a networking model that looks at all the plants and shows, all right, so you've got these parts that haven't moved in 5 years. This plant's using those parts. You should transfer it before they buy more.
Yeah. And I would be looking at why. Why are they consuming more of the part versus this particular location? Is it regional? Is it because of there's just so many other
questions. Tons of variables.
Yeah, you can just keep on going on it. One last sort of put your future hat on. Where do you see this stuff going? What are you looking at?
Yeah, what our goal is and what we're trying to build is what we call, it's a buzzword, but we have a large language model, but we're building AI agents to use that large language model ultimately. So when you buy the software, our end goal is limited interaction with this thing. So it's management by exception. Yeah. And so right now we make stocking recommendations. You agree, disagree. If you disagree, it asks a series of questions. Right. You're training this model, and it's like I would think of it as like a junior supply chain analyst. But as this thing gets better and better and more customers, and so right now we've got most of our customers are Fortune 100, Fortune 500 big industrial companies, and we're sitting on I think it's around 60 million master data SKUs with our customers, and it's around 10 billion transactions tied to that. Total inventory sitting in our system is around $20 billion of inventory globally. So it's getting better and better, but where this is going is this, like I said, this occupied space that we have is to automate. And so,
because I want it to magically I don't want to be notified, because this is what's going to happen. I get notified again, I get notified again, and I'm going to ignore it like I do my email.
Absolutely. What we want to build is a resilience and trust in the sense that in the first 6 months, you're just validating that this thing's working right, and then you let it do its job. And then it notifies you when it has a problem. And the less notifications, the better.
Yeah. That's cool, by the way. Versen? Verisen. Jeremiah, how do people get a hold of you?
You can look me up on LinkedIn, Jeremiah Woodford. Verisen.com is where you can find it. Go there, and if you guys, I highly recommend, get a demo. It's a really cool demo. It's really cool software.
It is. It's because you live near here. You have automated vehicles. It's just roaming around.
I'll leave you with one last. That we're in the future. I was in downtown Austin last week, and I was at a red light in the Waymo self-driving car.
I did it. I've been in them.
And so it was sitting beside me, and then the little robot that delivers food was crossing the street, and then an Amazon truck ran it over.
The future has some speed bumps.
It does.
All right. Thank you, Jeremiah. We're once again broadcasting from Xcelerate 2025. This is brought to you by the fine people at Fluke Reliability. Put this on your calendar for next year. If you're in the world of asset management, maintenance, or reliability, you need to be here. You need to start talking to people like Jeremiah, and you will not be disappointed. All right, we're going to wrap it up on the other side. Stay tuned. We will be right back.
You're listening to the Industrial Talk Podcast Network.
Jeremiah Woodford, the company Verisen AI, incredible technology. It's all giddy. I love it, man. how AI, how they're leading the way and being able to sort of impact MRO. Yes. That was a great conversation at Xcelerate. Really appreciate Jeremiah being on the show and sharing his insights, wisdom, and really solutions. It was fantastic. All right, again, we have an ebook, we have a workbook. It's all out in Industrial Talk. It is all focused on your success. We want you to succeed. We want you to educate, collaborate, innovate. We want you to have that vibrant culture that really separates you. And then, of course, we want you to tell your story in an effective way. Go out there, find out more. All right. Be bold, be brave, dare greatly. Hang out with Jeremiah. Change the world. We're going to have another great conversation shortly, so stay tuned.